This is the Core 2 video for our Quarter 2 final exam examples. The final exam is on similarity, trigonometry, and log, sines, and cosines. The first example I'm going to work is a similarity problem. I have two triangles, and I need to calculate the length of this side. Similarity means that the sides are proportional. Angles are the same, sides are proportional. So if I look at the shortest side and the shortest side, they have to be proportional to the longest side and the longest side. And that has to be proportional to the side in the middle and the side in the middle. So I'm going to compare this side to this side and this side to this side. I want to know how much bigger the 42 is than the 28. That's going to tell me how much bigger this side is than the 20. If I take 42 divided by 28, it gives me my scale factor. How much do I multiply by? 42 divided by 28 equals 1.5. I know that I have to multiply I have to multiply 20 times 1.5 to get this. If I want to get this, I take 20 times 1.5 times my scale factor. I know this is 30, and I can select answer A. Second example I want to work is a trigonometry example. Find the missing side. For trigonometry, the first thing we always do is find the hypotenuse. Second thing, I tried to start here. A lot of people always start here. You start at the angle you know, and you find the opposite side. And you label the other side the adjacent. And SOHCAHTOA reminds us that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. I want the opposite. I have the hypotenuse. So I look for opposite and hypotenuse, not opposite and adjacent, not adjacent and hypotenuse. I need the opposite and the hypotenuse. So I say sine of 51. I always put the angle, the degrees, in the trigonometric function equals opposite over hypotenuse. Opposite is x. Hypotenuse is 18. To solve this now, I multiply by 18 on both sides. We have to do the same thing to both sides. So x equals, after these cancel, 18 divided by 8 is 1. 1 times x is x. X equals 18 times the sine of 51. And on my calculator, I put 51 and then push the sign. And that gives me the sign is 0.7771. And I push the equals, it multiplies it by 18, and I get 13.98, which I will round to 14.0. So I select D. third example is also a right triangle. I know it's not Pythagorean theorem because I only know one side. And I'm looking for the other side, but I have an angle. So that tells me it is, once again, SOHCAHTOA. So I label the hypotenuse. I start at the angle, and I label the opposite. And the third side is the adjacent. So x is this value to the adjacent side. The opposite side is 16, and this is the hypotenuse. I look at SOHCAHTOA. I write SOHCAHTOA because it reminds me that the sine equals the opposite over the hypotenuse. The cosine equals the adjacent over the hypotenuse. And the tangent equals the opposite over the adjacent. And I look at what I want. I want the adjacent. I have the opposite. Adjacent and opposite. Sine will not work because it does not have the adjacent. Cosine will not work because it does not have the opposite. Tangent has the opposite and the adjacent. So I use tangent. And again, tangent. The angle comes right after the trig function. 57 degrees equals opposite over adjacent. 16 over x. And I don't want to work the problem this way. I'm going to say this is tangent of 57 divided by 1. And then I'm going to flip both sides over. I have a fraction on both sides. I can say that x over 16 equals 1 over tangent of 57. Now I multiply both sides by 16. And these cancel. That tells me x equals 16 times 1 divided by the tangent of 57. And I can do that on my calculator. 16, if you want to do times 1, you can. Divided by 57. And on the school calculators, you'll push the tangent first and then the 57. This calculator wants me to do the 57 first, and then I push the tangent. Tangent of 57 is 1.5398. And plus the equal. It divides 16 by that number. I get 10.39 or 10.4. Question number 4. Again, I have a right triangle. And I have two sides, but I am not looking for the third side. So I cannot use a squared plus b squared equals c squared. I am looking for this angle. I'm looking for an angle. So I need to use SOHCAHTOA again. I find the hypotenuse. I'm looking for this angle. So the opposite is across from it. And the side left over is the adjacent. So this side that's 4 long is the adjacent. Now I write SOHCAHTOA, which reminds me that the sine equals the opposite over the hypotenuse. Cosine equals the adjacent over the hypotenuse. And tangent equals the opposite over the adjacent. And I look at what I have. I have the hypotenuse and the adjacent. So I can say that, that tells me I need the cosine, because cosine has the adjacent and the hypotenuse. So I can write Cosine of x, because I always put the angle next to the trigonometric function, equals 12, adjacent over hypotenuse 4 over 12. And if the cosine of x equals this, then x equals the inverse cosine of 4 over 12. I go to my calculator, and I can do that. On the school calculators, you'll push the second function button, and then the cosine. Then you can put 4 divided by 12 in the parentheses. On this calculator, I have to do the 4 divided by the 12 first. And then I do the inverse cosine, which gives me cosine minus 1 of 0.33333. It tells me 70.5 is that angle. So x equals 70.5 degrees, which rounds up to 71. I want to work one more trigonometry example. I'm sorry, that's the last trigonometry example. Now I'm going to work a law of cosines example. So law of cosines, I'm going to write that really quickly. It looks a lot like the Pythagorean theorem. C squared equals a squared plus b squared minus 2ab cosine c. When we don't have a right triangle, we end up having to do something different. So I look at my triangle. In the formula, this side has to be across from this angle. The capital letters are the angles, the small letters are the sides. And if I'm going to make this work, this has to be the angle that I know. So the H, I'm going to change to a C. And then the other two, I'm going to change to A and B. So small c is over here, small b is over here, and small a is down here. Now I go to my formula. We are looking for c squared equals 7 squared plus 22 squared minus 2 times 7 times 22 times the cosine of capital C. I'm sorry, I will go ahead and put that in. We know that capital C is 47 degrees. So I put this in my calculator. With the graphing calculators at school, you can put that in directly. I have to start from the beginning. I have to use PEMDAS. So I say 47 cosine times 22 times 7 times 2. I'm going to call that negative 2 so that I can add it. And I get 210. Oh, I'm sorry. I need to start over. 47 cosine times 22 times 7 times negative 2. And that's this button. I change that to a negative 2. I get negative 210. Since I made it negative, instead of subtracting, I can now add. So I can say plus 22 squared, 22 to the second power, plus 7 squared equals 322.9. And a lot of people in class, when they get get an answer like that, they say that answer is just too big. And I agree. 322.9. It's just too big for that triangle. An excellent observation to make. We need to remember that we need to take the square root of that number. Square root looks like this. So the answer is actually 18.0. C squared is 322.9. C is just 18. And if you want to check that, you take 18 times 18, or you square 18, and you should get that same number. So my answer is 18. The second question is law of cosines again. But in this case, the second question is law of cosines, but I'm not given the angle. And you notice all the answers are in angles. So I have a triangle with 3 sides, and I need to find the angle x. I want to know what this angle is. And once again, I will use the law of cosines, but I will change my procedure just slightly. Nonetheless, this still needs to be C for my formula, and I can make this A and make this B, which makes 17 my little b, 11 is my little c, and 10 is my little a. So I go to my formula. C squared, I will write the formula. C squared equals a squared plus b squared minus 2ab cosine of capital C. Little c is now 11. So I do 11 squared equals little a is 10 plus little b is 17 minus 2 times 10 times 17 times the cosine of, and I have no angle, so this is actually going to be what I'm looking for. And as we talked about in class, that results in an equation that we need to solve. So first of all, 11 squared is 121, 10 squared is 100, 17 squared, 289, minus 2 times 10 times 17, or 2 times 170, 300 plus 140, 340. I'm going to check that. So now I end up with an equation. I can simplify that one step more. Have a 21 equals 389 minus 340 cosine of C. And when you studied solving equations, you had an x here. I want you to think about this like the x in the equations that you solved. When you were solving equations, you had a number times x plus or minus another number equals to a number over here. To solve this now, what you did when you did solving equations, you've got the variable, the x by itself. I'm going to get the cosine of C by itself. So I subtract 389 from both sides, because that's here by itself, or that's here kind of in the way of the cosine of C. But if I subtract it, I get rid of it, because 389 minus 389 is 0. And this gives me a negative since I'm subtracting a larger number. And I get 268. And over here I am left with a negative 340, because if I'm not subtracting 340 from 389, I'm subtracting it from 0. If I subtract a number from 0, I get a negative number. Cosine of c. And now I have my variable here, the thing that's acting like an x. It's multiplied by something, and that equals something. Undo the multiplication. We divide by negative 340. I know a negative divided by a negative is a positive, but I keep the rest of that in my head. So I'm going to do, on the calculator, 268, and I change it to negative. On the school calculators, you put the negative first, divided by negative 340, equals 0.7882. And here, I get 1. 1 times cosine of c is just cosine of c. I'm going to back up and fix that. .7882 equals cosine of c. And I know, if I know the cosine, I can find the angle by doing the inverse cosine, which we say cosine to the negative 1 power. Although it's not to the negative 1 power, it's just the notation we use. And I can do that again on my calculator by 0.7882. And I push the inverse button first. That's like the second button on the school calculator. Then I get cosine minus 1. And it tells me 37.979 or 38.0 degrees is the cosine. So I choose D. Law of sines. Law of sines is interesting. When I see two angles, I know I need law of sines. I can use law of cosines when I have one angle and two sines. When I have two angles on one side, I need to use law of sines. Law of sines says, and I will use these letters. With law of sines, it's easier to change the formula. With law of cosines, we like to keep the formula the same because it looks like the Pythagorean theorem when we say c squared equals a squared plus b squared. So I keep the formula the same. With law of sines, I change the formula. So law of sines says sine of k divided by little k. And again, little k is across from capital K, equals sine of h divided by little h, where little h again is across from capital H. And that also equals sine of capital P divided by small p, where small p is across from the angle P. And in this case, I need P because I have the 45 at the P. And I am looking for KP. So I'm actually looking for the side H because H is KP. So I'm going to change that to H. And I will say, so I'm looking for little h, capital H, little p, and capital P. So the h's and the p's are what I'm going to use. So I will not need this part of the equation. Problem is I don't know the angle capital P, but I know there are 180 degrees in a triangle. So if I subtract out these two, that will tell me this one. So I start with 180 minus 18 gives me 162, and then I subtract 37, which gives me 125. So I know angle P has to be 125. So sine of H is sine of 18. Sine of 18 divided by little h, which we're looking for. And sine of P is now sine of 125. Divided by 45. And I will take the reciprocal of both sides. Like we did before, I want h in the numerator. To get h by itself now, I'm solving an equation. I multiply by sine of 18. But I have to multiply both sides. Here the sine of 18 cancels. I'm just left with h. And here I have 45 times sine of 18 divided by sine of 125. So I go to my calculator. "45 times 18 sine," and again on the school calculators you push the sign first, divided by 125 sine, shows me the sine of 125, and on the school calculators you push the sign first, and you push equals 16.9758. I'm going to call that 17.0. So I choose 17. Sometimes with law of sines, though, I have to find an angle. So if I'm finding an angle, I have 108, and it's across from 40. I'm looking for the angle C. So I'm going to write my equation now in terms of the sides here. First of all, across from capital A is small a, across from capital C is small c, across from capital B is small b. So I write my equation. I'm going to try to anticipate this time. I'm looking for an angle, measure of angle C. So I want the angles to be in the numerator. So I will write the formula with the angles in the numerator. Sine of A divided by A equals sine of B divided by B. And both of those are also equal to sine of C divided by little c. I'm looking for C. I know C, I know little c, I know capital A, and I know small a. So A and C are what I'm looking for. I don't need the sine of B. So I say sine of A, sine of 108 divided by little a, which is 40, equals sine of capital C, which I am looking for. I will leave that as capital C, divided by small c, which is 13. To find C, I need to get C by itself. C now is divided by 13. That confuses the issue. I want to undo that division. Going backwards from division, or the opposite of division, is multiplication. I multiply both sides by 13. Here the 13's cancel because I get 1. Sine of C equals 13 times sine of 108 divided by 40. I need my calculator for that. Times 108. On the school calculator, you push the sign first, but I put the number first. That tells me the sign. This is the sign times 13. Now I divide by 40. And I get the sign of capital C equals 0.3091. If I know that sine of C equals 0.3091, then I know capital C has to be the inverse sine of 0.3091. And the calculator will do that for me. Like the second button, the yellow button on the school calculators, I have an inverse button. That gives me sine inverse. I click on that, and it tells me 18.00 degrees is C. And I select that as my answer.